Hello everyone, welcome you all to a new video on graph theory. So this will be the first video on graph theory in which we will explain what a graph theory is, why is graph theory used, and the basic terminologies that are associated with graph theory. So at the very beginning, let's start with what a graph is. A graph is nothing but a collection of different locations along with the paths that connect, or we can say the links that connect those locations. For example, we can take the example of several locations, several geographical locations. So those locations are having some paths, having some links that helps the people to move from one location to another location. So this entire thing we can consider as graph. Similarly, for example, network. In computer networks also, or in mobile networks, whatever we consider. So the different devices are there, and there is a link between all of them. Either it is a wide link or it is a wireless link, whatever it is, but there is a link in between them. So in all these cases, the concept of graph theory is used. So if we can consider a simple graph of this type, here we have the different locations as location 1, 2, 3, 4, 5. We can say that these are the different locations or geographic locations, or these are the different devices, whatever we consider. So these are the different locations or devices, and these the lines in blue color represent the links between those locations. So combining all these things, we can consider it as a graph. Thus, what we can say, a graph is a combination of vertices and edges. Now, what are these vertices and edges? The vertices are the locations. All these locations are referred to as vertices. However, the links between those vertices are referred to as edges. So, for example, in this case, we can see that the set of vertices are 1, 2, 3, 4, 5. These are the 5 different vertices. However, the edges or the links are, since we have a link from 1 to 3, so 1, 2, 1, 3, 2, 5, 2, 4, 3, 5. Since we don't have a link between 3 and 4, so that is not coming here. So these are the vertices and these are the edges. So set of vertices is represented by V and set of edges is represented by E. Vertices, the plural form is vertices, the singular form is vertex. So we can say 1 is a vertex, 2 is a vertex, 3 is a vertex, similarly 4 is a vertex, 5 is a vertex. Collection of defined vertex means vertices. So the defined vertices are this and defined edges are this. These vertices are also referred to as nodes. Whenever we are referring to networks, we refer to them as nodes. Whenever we refer to them as geographical positions or geographical area, then we refer to them as specific locations. So these are the defined locations in a geographical area. So this is the basic thing about graph. So it includes vertices and edges. Therefore, we can define a graph. So graph G, if this is a graph G, then G is represented by V, E, where V is the set of vertices. V is the set of vertices, and E is the set of edges. As we have seen here, for this particular graph, we can say this is the set V and this is the set E. So that is all about the definition of graph. There are many uses of this graph theory. It can be used in networking. It is used in even the Google Map. Google Map is also using the concept of graph. Networking, traveling salesman problem, and there are many such areas where graph theory is very much necessary, is very much used. So this is about the introduction of what a graph is. What is vertex? What is edges? In this graph, we have seen that this is the path, or you can say this is the road that connects the location 1 and location 2. So since this is a road or is a link, that link can be one directional or can be bidirectional. So if no direction is associated with a particular link, then we refer it as undirected graph. However, if a direction is assigned with the edges, then we refer to them as directed graph. So we will discuss the concept of directed graph and undirected graph while discussing the types of graph. There are different types of graphs, so we will look into that. Now let's look into some basic terminologies that are associated with graph. So we have got what is vertex, what is edges. Now we will look into the other terms. Let's look into the term adjacent vertex. What adjacent vertex means? The term adjacent means nearby. So now if we consider in case of graph, in two locations, or in case of geographical area also, two locations will be considered adjacent if there is a direct link between them or direct connection between them. So if we look here, there are 5 vertices, out of which we have direct link. If we consider one, the node 1 or the vertex 1, the vertex 1 is having direct connection or direct link with 2 and 3. So we can say that the vertex 1 and 3 are adjacent. They are adjacent vertex. Similarly, 1 and 2 are adjacent. However, 1 and 5 are not adjacent because there is no direct link between them. So that is the meaning of adjacent vertex. So we can say any two vertex A and B will be considered adjacent if there is a direct path, or we can say direct link between them. So I am repeating it once again. Two vertex A and B are called adjacent if there is a direct link between them. So that is all about adjacent vertex. The next term is path. So what a path means in case of graph. Adjacent vertex means they should be close to one another, but path means the path or the way through which we can move from one vertex to another vertex. For example, suppose path from say 1 to 4. So what is the path from 1 to 4? The path from 1 to 4 is, it can move from 1 to 2. To move from 1 to 4, there are many ways. So one is 1 to 2, another is 2 to 4. So it is moving from 1 to 2 and from 2 to 4. So this is one path from 1 to 4. Let's take another path from 1 to 4 is 1, 3. Then from 3 it will move to 5. From 5 it will move to 4. Another path, yes, another path is also there. It can move from 1 to 3. It can move from 3 to 5. Then from 5 to 2. Then from 2 to 4. It can move like this from 1 to 3, 3 to 5, 5 to 2, 2 to 4. So we have seen that there are 3 different paths from 1 to 4. So out of that, if a traveler wants to travel from 1 till 4, they will use the path which is shortest. So generally they will take the path 1 to 2, 2 to 4, because this will be a direct path. So this number of edges that are associated with a specific path is called path length, because this is one edge and this is one edge. 1, 2, 1, 2, this is one edge. 2, 4, this is another edge. That means its path length. What is its path length? It is 2. What is its path length? It is 3, because the number of edges that it has to cover to reach from 1 to 4. 1, 3, 5, 4. So it is covering 3 edges. So therefore its path length is 3. Similarly, if the traveler is taking this path, then it is coming from 1 to 3, 3 to 5, 5 to 2, 2 to 4. So in that case, the path length will be 4. So this is called path length. So what is path? Path means the number of edges that the traveler has to cross through or go through to reach the destination, because here the source is 1, destination is 4. So to go from 1 to 4, it has to pass through 2 edges. So this is the path, and the number of edges it is covering, that is called path length. So path and path length goes together. So path and path length. The next term is cycle. So what a cycle is? Now if you observe properly, if a traveler wants to start from 2, that is its source is 2 and destination say 4, not 4, let's take the destination 3. If a traveler is starting from node 2 and traveling to node 3, so how can it move? It can move from 2 to 1, 1 to 3. However, if we look, if it is going like this, that means if it is moving like 2, 1, 1, 3, 3, 5 and 5, 2. So this can be considered as a cycle. Means what you can say, here you observe that the source and destination is different. But however, if you put it 2 here, in that case the source and destination is the same. In other words, we can say graph will contain a cycle if there is a path in which the starting vertex is same as the ending vertex. So in that case, it is called a cycle. Similarly, there is another cycle also, 2, 5, 4, 2. If one starts from 2, he can just travel and again move to 2. So that is called cycle. So those paths in which the start vertex and the end vertex are same, it is called a cycle. So path is nothing, cycle is nothing but a path having starting and ending vertex as same. So that is called cycle. The next term is weight. Weight of an edge. So it is also termed as edge weight. We can say edge weight. What is the meaning of this weight? Weight means the cost associated with a specific path. For example, to move from 1 to 2, to move from location 1 to location 2, the cost required is, say for example, 5. To move from 1 to 3, cost required is say 3 rupees, 3 to 5 say 2 rupees, 5 to 2 say 7 rupees, it is 8, and it is say 6. So in that case, we can say that to move from 1 to 2, if it follows this direct path, it will require 5. So this 5, 3, 2, 7, 8, 6, these are called the edge weight, or we can also call them cost associated with a particular edge. Cost associated with a particular edge. It is called weight of that particular edge. So now, what is the use of this? For example, a traveler has to move from 1 to 5. The traveler has to move from 1 to 5. So what path can it take? It can take, the traveler is moving from 1 to 5. So there are many paths. One path it can take is, it can move from 1 to 2, then from 2 to 5. Because there is no direct path from 1 to 5, so it will have to move through 2 or through 3. So it is moving through 2. So 1 to 2, then 2 to 5. There is one path. Another path is, it can go to 3, 1 to 3, then from 3 to 5. So 1 to 2 and 2 to 5, 1 to 3 and 3 to 5. So what is the cost associated, total cost associated with this? So from 1 to 2 it will cost him 5 rupees, and from 2 to 5 it will cost him 7 rupees. That means it will be 12 rupees. However, in this case, from 1 to 3 it will cost him 3 rupees, because 1 to 3 it is 3, plus 3 to 5 it is 2. 3 to 5 it is 2. So cost is 5. So which path will the traveler take? If he is considering the cost, he will definitely take the second path, because in this he or she requires only 5 rupees to travel from 1 to 5. However, if he travels along this way, then it will cost him rupees 12. So therefore, the age, weight, or cost, or whatever we call it, or weight, so is important. We have to know, so what is the cost associated with a particular age. Now this cost, not only in terms of money, it can be in terms of time also. Suppose it is taking much time to reach, however it is taking less time to reach. This tree can refer to any minute, second, hour, or whatever it is. So it can be a time also. Therefore, the common term that is being used is weight. Weight associated with a age. So that is all about weight. There is another important term, loop. We can say that a graph or an age is having a loop if it has something of this type. Not only directed, can be undirected also. So loop means if there is a path that, or not only path, if there is an edge, it is not a path, it is an edge that starts with a vertex and ends with the same vertex. If we have to define all the other edges excluding this, how can we define? It is 1, 2, 1, 2, 1, 3, 2, 5, 2, 4, 3, 5. However, if this is also there, then along with all this, we will also have to write 3, 3. That means we are having an edge in which the starting and ending vertex is same. So if such an edge is present, it is called loop. Loop means, in other words, we can say an edge having the start and the end vertex same. So that is called loop. For example, this similarly this can be with any one of the vertex. So that is called loop. So another term associated with this, we can say, if we consider another type of graph. For example, let's take a graph of this type, say 1, 2, 3, and 4. So here we are connecting all the vertices with one another. All the vertices are connected. One is directly connected to 2, 1, 3, 1, 4, 2, 1, 2, 3, 2, 4, 3, 2, 3, 1, 3, 4, 4, 3, 4, 2, 4, 1. So all the vertices are connected. If all the vertices are connected, that means we can say it is having maximum edges. Maximum edges. So we have to remember this term. If a vertex, so minimum and maximum edges. For example, in this case, total vertices, let us identify it by n. Total vertices are 4. So total edges are, how many edges will be there? There are 6 edges. 1, 2, 3, 4, 5, and 6. So there are 6 edges. Similarly, if we see, so this is the maximum number of edges. So it is generally identified by minimum. Minimum number of edges will be n minus 1, and maximum number of edges will be n into n minus 1 divided by 2. So you have to remember this. So minimum number of edges, so that all the vertex remains connected, is n minus 1, and maximum is n into n minus 1 by 2. So so how is this computed? So let's take the example from this only. So if we have to connect all the vertex 1, 2, 3, 4. So this can be connected. So how many vertex, how many edges are required? 3 edges. So what is the number of, what is n? N is 4, 4 minus 1, 3. However, for maximum, how many edges are required? It is 4 into 4 minus 1 divided by 2. 4 3s are 12, divided by 2 is 6. So this is the general formula for counting the maximum and minimum number of edges. So with this, the basic terminology that are associated with the graph is discussed. In the next video, we will see how these terms can be used in the different types of graphs. So we will be discussing the types of graph in the next video. So thank you all.